Namaskar and a very good evening to all dignitaries, faculty members, staff, and students. With great joy and immense exhilaration, I feel privileged to extend a very warm welcome to all present here. I am Professor Srivastava from the Department of Mechanical Engineering, and it gives me a great pleasure to host the event and welcome delegates, Dr. Priyambada Tripathi, Mr. Sujit Bhattacharya, and Dr. Subhrajit Bhattacharya. On behalf of Amity University Great Noida Book Club, and every year on 22nd December, it is observed as National Mathematics Day in India to commemorate the first anniversary of legendary mathematician. And he was Srinivas Ramanujan. The day marks the importance of mathematics in our life and encourages people to develop self-learning and rational thinking. Former Prime Minister Dr. Manmohan Singh declared 22nd December as National Mathematics Day 2012, and India celebrates National Mathematics Day to honor the mathematical expression made by Ramanujan, which opened new arenas of mathematical research. The path-breaking work of Ramanujan remains an inspiration for future generations. Now, in the sequence of celebration of the Bharat Ka Amrit Mahotsav, the AUGN Book Club, that is Amity University Great Noida Book Club, has organized an author talk on Practical Handbook of Machine Learning. This book provides a hands-on approach with live examples to machine learning written for engineers, college students in their second or third year of BTech, as well as for professionals, faculty members who want to learn this exciting field on their own. The book focuses on explaining concepts of machine learning which are important in application. So let's get started with this wonderful and exciting session as we have the author himself here to guide us more upon this. I would now read the brief profile of the author and thereafter I'll request him to take over the session. We have with us the author of the book, Mr. Sujit Bhattacharya, and he's one of the founders of CLSK and is an alumnus of IIT Kharagpur and IIM Bangalore. As the Chief Innovation Officer, he currently leads all digital initiatives, including the data science practice in CL, a hands-on technologist, and a passionate teacher. He has led CL into the adoption of AI, ML, and voice tech, and was invited to Amazon as a part of Flexible Developer Advisory Council. He has served in the 50 Committee for School Education and has invited faculty to AICTE for conducting faculty development programs in the areas of AI and machine learning. Welcome, sir, and we are very privileged to have you here.
Thank
and
you.
I now request you to please take over the session. Over to you, sir.
Okay, thank you very much. A very good afternoon to all of you present here, Dr. Singh, Dr. Tripathi, Ruchira, all faculty members and students. I'm very happy to be here to speak on one of my favorite subjects, machine learning. And it is indeed very commendable that you have chosen to host conversation on machine learning on such an important day of National Mathematics Day. And I think the whole world is transforming because of artificial intelligence and machine learning, and the foundation of mathematics on which it is based is only making it possible. So I think this is a very apt tribute to the wonderful work which has been done by the genius scientists, mathematicians way ahead of us, and today we are reaping the benefits. So what I'm going to do is I'm just going to make a simple assumption that maybe not everybody who's attending this talk is perhaps aware of machine learning and what it can do, and I will try to kind of arouse a little bit of curiosity in all of you who are attending and who are probably curious about machine learning and want to know a little bit more. And so I will tell a little bit of a story and a few things about machine learning, which hopefully will intrigue you and make you curious to learn more. And after that, I can take questions, and I will mention the book at the end, but my intent is more to talk about the subject and not so much the book right now. So I will like to use a presentation. So let me just share the screen for that. I hope my presentation is visible to all of you.
Yes, sir.
Yes, please.
Okay, excellent, excellent. So quick question, and I'm sure we already know the answer. Have we used machine learning today? And I would be happy to hear a quick response from one or two of you. If you have used machine learning today, where have you used it?
Yes,
Yes?
I request from the students if they
Yes.
can answer.
Yeah, anybody. I mean, faculty, student, anybody. Just a quick response. I'm not watching the chat box, so you will have to speak. I'm sorry about that. Okay, I
Sir,
can
I
see the
believe
chat box. Yeah, in phone. Yeah, I can see. In phone,
Uh,
in Zoom. Okay.
the two of the students have answered. Pooja Singh, she said in phone, and Shekhar Suman Jha. Zoom.
Yeah. Can you be a little bit more specific, Pooja and Shekhar? A simple where we've used machine learning in our.
Sir, in specific, you want to be little more specific.
Yeah,
Mr.
image
Gaurav,
processing. Okay.
image processing.
Okay. All right. So these are something which I'm sure all of us have done today. Okay. In whether it's seeing a Google Maps or definitely a WhatsApp message, you might have typed out a message, and or you might have spoken to your phone or Alexa or something like that, or you might have just gone to YouTube, or you might have gone to Amazon and you might have checked out a video or something. And it is remarkable that our everyday common experiences are today very much influenced and controlled by machine learning. So when we look at Google Maps, and when it says, okay, it's going to take 18 minutes for me to go from my home to my office, this is a prediction, when it says 18 minutes to this place, and that is based on machine learning. And when I'm talking to Alexa, the speech which is picked up, the speech recognition part, and the understanding what is my intent, what am I asking for, all of this is impossible to do without machine learning. Or the videos which are shown to me when whenever I go to YouTube or Netflix or Amazon or wherever I am, these are all built using machine learning. There's nobody who has sat down and written code that if so and so person logs in, then show him this. That has not happened. Okay. And as we go ahead, I will kind of give you a little bit of a feeling of how this happens. And then when we type messages and you see WhatsApp is going to recommend the next word, or correct the spelling and things like that. These are all very simple but very remarkable examples of machine learning in use. And as much as it seems very simple, and we use it all the time, but it is really based on some very, very interesting principles, and these technologies kind of completely change the way we look at things. So before I move ahead, just a very quick explanation of a few terms. There are lots of terms in this, in AI and machine learning. So firstly, AI, and I think AI and machine learning are very, very often used together. Okay. And if you kind of read a newspaper or something, people will just keep switching between the terms AI and ML, and all of us probably do that. So let me quickly tell you, AI basically refers to this whole idea that us human beings, we can whatever we do, it can be replicated by computers. The computers can behave like us, they can talk like us, they can solve problems like us. And that's kind of a dream, that it's a ambitious human endeavor that we have, that one day computers will be able to do this. And AI broadly refers to this ability of machines to do things similar to us. So let's just leave it as a broad idea, whereas machine learning is something very specific, and it's a bunch of libraries which we use in code, which can solve some very concrete kind of problems. Okay, and the input to machine learning is usually the data. And if you provide enough relevant data to machine learning algorithms, you will see that they are able to do very, very fantastic problem solving for us. And we don't necessarily have to give very explicitly programmed instructions. I will go into this a little detail, because it's very interesting that how, without giving explicit instructions to a program, how the program can actually do our work for us. Okay, and then you would also heard terms like neural networks and deep learning and deep tech, and there are lots of terms like that which are floating around. This is nothing but a subset of machine learning, which uses a particular set of algorithms called the neural networks, which are based on the neural networks for solving a same kind of problem. So it's not that the neural networks are solving any different types of problems. It's the same set of problems which machine learning solves. But these are meant for much larger amount of data. When you have a huge amount of data, or when you have a lot of complexity, then we tend to use deep learning problems. So for example, when Siri or Alexa or Google understands our voice, the complexity of that problem perhaps cannot be solved by machine learning algorithms, which are more foundational algorithms. They will need a more advanced deep learning approach. So these are three terms which I thought I will clarify. There are lots of other terms which have come into our terminology, data science or cognitive computing, or things like big data, predictive analytics. They mean a lot of different, they are very similar because the field has evolved over like 50 or 60 years. So different terms have come and gone, but by and large, we can kind of collapse everything into one common term called machine learning. So a quick definition of machine learning. So there are many complicated and simple definitions. I just like very simple definitions. And basically, this is a definition which says machine learning allows computers to learn from data and solve our problems, learn and infer from data. So this could be one of the very simple example or a definition of machine learning. I'm not going to go into the formality of this definition too much, and I'm going to straight away, pose a couple of problems for you. Okay, let's look at this problem, which may be, before us. And I understand most of the students who are attending are all, computer science department or engineers at least, and you'll be very uh, intrigued to know how this problem gets solved. So, for example, the problem is, let's say I have been told that, we have handwritten digits, and you can see I've put a sample of handwritten digits out here, which are basically a bunch of zeros and ones and twos up till 9. And let's say, I have to create a system which, if somebody gives me a handwritten digit, okay, so let's say, somebody, writes 6 like this, my system should be able to read this and say, okay, this is a 6. Okay, that's the program that I need to write. And let's say I'm not a programmer, but I'm good at organizing logic, and I have 10 of the world's best programmers who are ready to work with me, and all I need to tell them is I need to give them the logic, and then they will write the program which can do this. So let's see if we can even attempt to solve this problem. So let's say, the way I would do it is I would say, okay, first I will give the logic for recognizing a 0, and then I will give the logic for recognizing a 1 and 2, and so on and so forth. So there will be at least 10 different blocks of code in my solution. And if I have to solve the problem of 0, then I'll tell my programmer that, look, if there is something which is kind of circular in nature, and maybe I will look at the geometry of this. I'll figure out some way of saying that, if there is one part of the curve like this and another part of the curve like this and something like this, that there are 4 parts, then this is a 0. Okay. And similarly, I will do this for 2 and 3 and 4 and 5. I'll try my best to give the logic to the programmers. Now, it is very easy for all of us to see that this is not it is not a simple problem to solve. Because when we talk about human handwriting, all of us tend to write numbers in different ways. So, we are not even careful with our writing. And so sometimes you can see a 0, which almost looks, you can't make out that it's a 0. Or if you look at, this row of 4s, if you can see on the screen, this is a very poorly written 4, but you and I can make out this is a 4. So how am I ever going to teach a computer algorithm to recognize that this is a 4? And then some of us tend to write 4 like this, or see, look how poorly this is written. And if you come here in this row of 8s, you can see that, this little number out here, I mean, any human being can say that's an 8, but very hard for us to kind of put some logic to recognize it. Now, this is where machine learning actually comes in, and machine learning actually is able to solve a problem like this with amazing amount of accuracy. So, if you take a very standard textbook code, you would probably find you'll be able to solve this with 99.99xx, this level of accuracy. Okay, which means if you give 10,000 different digits to my program, I'll probably not make more than one mistake. Okay, so that's and the machine learning code will actually will do it in about maybe 20 lines of code. Okay, and I will actually complete this job in maybe 2 to 3 hours. I'll be done with it. Whereas if I and my team of 10 of the world's best Java programmers try to solve this problem, I don't know if I'll be able to solve this problem with this level of accuracy. Maybe never be able to reach this, and it might take me maybe 1 to 2 years to come up with something which can hit a reasonable level of accuracy. So this is a very there are certain things which are the traditional computer science which we learn cannot solve these kind of problems. So why is this problem so difficult to solve? Let's spend a little time on this. Now, the first problem is that, firstly, when we write programs, we write to a particular, let's say, a law or a formula. So we tend to write using if statements, right? If we say if something, then something, some actions, okay? And we have very definitive instructions which we put out here. If something is less than something, or if something is bigger than something, we can deal with very firm rules. But if you see this problem that we have out here, there is no uniform rule you can tell me for how a 0 is to be recognized or how a 4 has to be recognized. The rule itself doesn't exist. The input itself is not uniform. Sometimes my 0 looks like this, sometimes it looks like this. It can be horribly out of shape, and I still need to make my program work. When human beings look at these digits, we are able to very quickly do it, because we know that this doesn't look like a 8, but it is probably an 8. So we use probabilistic logic to actually solve problems in human, what we do in day-to-day life. And also, when we see a bunch of numbers, so if this was a, if you were teaching a 2-year-old to recognize digits, you would realize that, the first few times the child would get it wrong, but eventually the child will stop making mistakes, because learning success actually grows with the number of examples that you see. And similarly for machine learning, if you give it 10 data points, it'll achieve a certain amount of accuracy. But if you give it 10,000 data points, it'll go to almost perfect. It can go to as perfect accuracy as possible. So these are some of the skills that we use in human life, and actually machine learning is able to incorporate a lot of these things. So when machine learning solves a problem, it is able to deal with, if there is no formula or a law which can be coded, it will figure out the next best option to it. If the input is non-uniform, it still has some margin of error in which it is able to predict correctly. It is able to use probability to make close judgments to what should be the right answer, and it genuinely learns more and more as the data grows, and it is able to even do things what is called analogizing, which means similarity, looking for similarity. So this is the kind of power of machine learning. To summarize it in a little diagram, so a traditional program that we write using C or Java or something like that, uh, will basically, we will code this algorithm out here. And then if you put in some input out here to the algorithm, you will get a result. And that is how we generally do our programming. In machine learning, what we do is we look at past data. We look at historical data. And we don't try to, write these step-by-step code or the logic. We don't write it. We just don't write it at all. What we do is we take the past data and also the results that we have obtained out here, we feed both of them to the machine learning algorithm. And we allow machine learning to find the pattern and generate the algorithm. And once that is done, then that algorithm can take any new data and give a prediction. Now, one simple example of this could be, if a bank has written some logic for approving loans. Okay, so if you say, okay, a customer has got a certain amount of salary, and he has a certain age and so many other variables, and we write some code, if this is above something and this is below something and so on and so forth, then the result is, okay, the loan is approved. Okay, now when we do it through machine learning, what we'll say is, okay, take all of last year's data and you give me what was it that you had approved or unapproved, and I will take that last year's data and I will feed it to the machine learning algorithm, and it will create a new code, the algorithm, which will be able to do this kind of prediction by looking at any kind of a new application which comes into the bank today. So this is how machine learning kind of creates code for us instead of us having to write code. So here is a small little example. This is a little puzzle, and let me see. I'm sure we'll be able to solve the puzzle. It's like, what you see in this analytical tests and things like that. So there are 3 numbers over here, and the person who has made the puzzle says that, okay, if it's a 4, 1, and 2, then the answer is 9. And if it is a 7, 3, and 2, then the answer is 17, and so on and so forth. I'm sure it's a very simple problem, and all of you would have figured out that, maybe if I, kind of multiply this with this and then add this, I will get this number. So the answer over here should be, maybe 12 into 2 plus 5. And then I can check over here. Yes, the formula is holding. I can check over here. Yes, the formula is holding. And I can safely say, okay, I've solved the problem. And this answer is nothing but 29, because I've used my human logic to do this. Now imagine if this was to be posed as a machine learning problem, then we would not have to tell the machine learning or the computer that, if there are 3 values, say 12, 2, and 5, then the answer, the result is, if I call this x1 and x2 and x3, then the result is x1 into x2 plus x3. And this kind of simple problems we can easily do, but what if the relationship was complicated? You and I would not be able to solve it. And what if the relationship had not just 3 numbers out here, but let's say 300 numbers? We would have probably never been able to solve it, however intelligent we might be, or it might take us months or years to solve a problem of that complexity. And that is where machine learning is able to do this in 3 lines of code with such simplicity that it is just amazing. So how machines learn, when the concept of machine and learning is actually a mathematical concept. And what it does is it looks at a problem, any kind of problem, whether it's a face recognition problem, or whether it is, trying to predict how much time it will take. it looks at the problem as a parameterized model. Okay, so it takes as many variables as you throw at it, and it looks to find out what is the relationship, this function, where if I combine these variables x1, x2, x3 in as many different ways I want, I get my required y, the outcome that I want. So machine learning's algorithms actually work, and what they do is they do some stupendous amount of mathematics. They search through, all possible combinations of x1, x2, and all these variables, which captures the relationship with what outcome we want. Okay, so this is how machine learning learns, to explain it very quickly. And if I take a similar puzzle to the one which I showed here, here's a simpler puzzle. There are only two variables out here, and we are asking you to guess what is the y value out here. You can say that this machine learning problem can be represented as a function of x1 and x2. And this one is a little bit more tricky. You might not be able to quickly get the answer immediately. But the best part of machine learning is that irrespective of, how many variables I have or what is the relationship between, the same code solves a problem. So you can actually, write 5 lines of code to solve this problem, and solve 100,000 or a million different problems. Each problem is different, but it still solves it the same lines, a few lines of code. And that is the power of machine learning. So even things like, image recognition happens the same way. And, we unlock our phones using our faces. And it is just amazing that it is able to take my own face or any kind of image and convert it into some variables. So for example, if you're curious to know how this would be, we started our discussion with how will you recognize a digit? Well, a computer will save this digit as pixels. We all know this, pixels. So, if this is a kind of a 6 into 6, it's a 36 pixel image. But, modern day cameras and all that will save this in possibly in 36 megapixels or whatever. But the idea is very simple. It looks at this image as nothing but a bunch of numbers. Okay. And to it, this is x1 variable, this one is x2 variable, this is x3 variable, and this is like x36 variable. So it's a problem of where y is 4, it is a problem of combining these 36 variables, x1 to x36, and looking for a pattern, a mathematical pattern, which gives me an output of 4. So if you give the machine learning algorithm maybe 100 examples of how 4 is written, it will find a pattern between these 36 pixels and actually solve the problem for you. So I know I'm going very fast, but the idea is to kind of give you a very quick insight into how machine learning actually simplifies problem solving, the most complicated problems, which might take us, huge effort and time to solve, how it is able to completely change the way we solve the problem by looking at it as a bunch of mathematical equations. And the best part is machine learning takes the responsibility of solving that, the relationship between the variables and looking for that equation. You don't have to do it. Okay, you just need to worry about the implementation. So this is the power, and therefore let me just highlight one point from the slide, that machine learning can actually find millions, literally take in just millions of variables, and then identify any kind of even a non-linear relationship and build model. Now, when you worry about self-driving cars, when you wonder about self-driving cars or things like robotic surgeries and all that, these are such complicated problems that they indeed, there is an interplay of millions of variables in designing these solutions. And there is no way that you and I can actually write code to do it. We have to depend upon machine learning as the way. So that is why, we say that machine learning can actually surpass human creativity. And there are many examples of that. Now, I will just come to a few more examples, but let's say why has AI become so powerful today? And it's very simple. The computing power has increased, the storage cost has almost become zero, and the amount of data which is available to us is also increased hugely. And this is actually the fuel on which machine learning works. So if we have to solve very complicated mathematical problems, we need very powerful CPUs. And then, of course, we need to be able to save that data, and we need, if you want to solve a problem of, what is the distance between, Noida and the New Delhi railway station, or how much time should it take? I need literally tens of thousands of examples to be able to estimate, what is the time required. So that digital data is very important for me. So I will skip through a couple of these things and just come to a kind of a summary slide, that machine learning is omnipresent. It understands our language, and all that because you see Siri and Alexa kind of completely understanding what we are trying to do. We use Facebook, Netflix, Google all the time. Our family linkages and everything else is held together by some technologies like Facebook. So they kind of, machine learning is present every aspect of our life. In marketing and advertising, obviously, the way Amazon shows us what should I buy, and what Netflix shows us what I should watch. The entire e-commerce of the world is driven by very complicated logic, which is made possible through machine learning. So there are millions of examples in each. I will not get into it today. I think what is important is to kind of understand, if you are in college today and you're looking at a career ahead of you, how does machine learning, and what is the impact which machine learning is going to have? I think all of you are already aware, but let me kind of give you, this is a report which was published in 2018, and I haven't, worried about getting the latest future of jobs report. This is published every year because it still is so very relevant. What they said in 2018 is that by 2022, 85% of all CEOs in the world of the largest companies would have expanded their adoption of big data analytics, which is basically data and machine learning. Okay. And this is already a reality. Okay. Secondly, they said that there'll be 4 technologies which is going to dominate. One is the mobile internet, the artificial intelligence. So this is like 5G. 5G is going to come in and make a huge impact. Then artificial intelligence and big data, which is pretty much the same thing, and the cloud technology. So if you are a computer science student today, and you would be worrying about your, what kind of specialization you should be doing, or what kind of job you should be looking for, this is a clear indicator of where you should be going. Okay. And so don't kind of get lured into going for the most high paying job, because the future is going to be dependent on some of these technologies, and these will eventually become the most rewarding jobs if they are not already. So note these for yourself. What the future of jobs report said is that these will be the in-demand roles. Okay. And right on top is something called data analysts and scientists. So we know that data science is very hot, and AI and machine learning, and even things like, sales and marketing, which is always going to remain important, or HR and stuff like that. They've put a little asterisk on this. And this is very interesting to note that they're saying that even traditional jobs, like sales and marketing, or law and stuff like that, they will get impacted by AI and machine learning. And that depends. And if you're not aware of the nuances of machine learning and AI in your own field, you will start lagging behind. And machine learning is now solving so many problems that it's going to make a lot of these other jobs decline. Okay. So things like data entry and accounting and payroll, and a lot of audit work and stuff like that is going to become gradually replaced with machine learning algorithms. So there's going to be a huge impact on the job market in the next 5-10 years. But I think it's important for us to kind of focus on what is going to be in demand out here. Okay, so this is the book, and I've given you a little background about machine learning, and I've tried my best to, in half an hour, to make it sound very intriguing. But the book, the way I have written the book along with Subhrajit, my co-author, is we said that we will make this into a practical handbook of machine learning. And I when I have learned the subject myself and I've gone through hundreds of different books, I like the books which are practical, which take business examples, real life examples, and solve them in simple steps and explain it. So the book was written with a purpose of, making it like a one semester introduction to machine learning, and not just for a student of computer science, but any engineering student, or if not an engineering student, even a first year MBA or a BBA student. The only expectation is that you should be able to understand and learn Python, because Python is a very good language in general, and of course absolutely essential for machine learning. So though there are other languages in which you can do machine learning, but Python is like a very essential language for that. So the book is written in that format. It's very simple. It leaves out a lot of the theory and the mathematical stuff, which you can always do later. It tries to get you into the heart of the problem quickly. We basically deal with two types of machine learning. One is called supervised and one is called unsupervised. And when you get into the subject, you will understand. But these are broadly the two big areas of machine learning. Both are covered in the book with sufficient examples. We take a lot of practical examples. So we take from the healthcare industry how to predict insurance premiums. We do a cancer prediction problem. We also do a problem which helps you understand how YouTube or Netflix recommends movies to us, or how a Spotify recommends music to us. And so these are clustering algorithms and recommendation engines, which are basically unsupervised algorithms. So there's a reasonable balance of both in the book. And there is a website in which you can kind of there's a scratch code on the book, and you can register the book, and then you get access to about more than 20-25 videos which I and Subhrajit have recorded, and which actually kind of explain details of it's like a full online course on machine learning. So that kind of comes along with the book, so it can be quite useful to you. So I will stop here and take some questions. If there's anything that you want me to elaborate on, I'd be happy to.
Thank you so much, sir. We thank you from the bottom of our heart for taking time from your busy schedule and to be the guest speaker at our webinar. Your presence and wise words has helped to magnify our cause in the best possible way. Thank you so very much for attending this session and guiding our students as well as the faculties. We will take up the questions at the end. We have another guest speaker. After that, we will take up the questions for sure, because I'm getting n number of questions, and you can also see the chat box on my screen, and as well as we have got some other questions. So we will take up these question and answer at the end. Before that, we have another invited guest, Dr. Priyambada Tripathi. She is PhD in mathematics on the study of chaos synchronization in certain non-linear dynamical systems from the University of Delhi in 2015, and MSc from the BHU, that is Banaras Hindu University. She is also a CSIR GRF holder, and she is an eminent resource person on career opportunities in mathematics. Currently, she is working as a professor in Advanced Singh College, University of Delhi, and is an active in further research work on non-linear dynamical systems, as well as the author of a book and is still writing a book. So I invite to Dr. Priyambada Tripathi. Please take over the session. Over to you.
Thank you so much, Ruchira. And first of all, I hope I'm audible and my video is visible to everyone.
Yes, you are very audible, and I hope you can continue now. Yes.
Thank you so much. And thank you, host, and thank you, Amrit University, for giving me this opportunity to be a part of this wonderful session. First of all, I would like to congratulate authors of the book of machine learning. I'm very, very happy to know that how this mathematics is going to be used in machine learning. And Sujit sir has clearly very explained, given very good explanation for the machine learning, because I did not know anything about machine learning and I was completely layman about machine learning. And maybe I'm tempting to buy this book because I really become interesting, like, wow, how mathematics is going to be used. And yeah, sir said this machine learning is omnipresent. I did not know at all how it is interesting. So thank you so much, sir, for letting me know all these things. Thank you. And now I congratulate each and every Indian for 134th birth anniversary of the great mathematician Srinivasa Ramanujan. Let us celebrate his birthday. So I would like to present my screen. I will not take much time because I know there is a time constraint. So I would like to present my screen for only few minutes. So I would like basically, I cannot talk about the higher research and all, whatever Ramanujan has done in a very small lifespan of his. But yeah, we can discuss, we can see what is the basic work of Srinivasa Ramanujan. So I will share my screen. Just wait a minute. So here it is, untold. I hope I'm audible now. I have just switched off my video so that network issue will not be.
Yes, you are audible.
Okay, so here it is, untold connection between life and mathematics. One always wonder what is the relationship between life and mathematics, and one we always ask where we are going to this mathematics and this mathematics in our life and so on. So people just like making fun of mathematics. Oh, this algebra, this analysis, where we are going to all these mathematics. So basically, just like machine learning is omnipresent, I really feel that mathematics is also omnipresent. So first of all, let us not go to detail. Let's say that. So here, all of us celebrating the 134th birth anniversary of the great Indian mathematics genius, the man who knew infinity. So wishing you all happy National Mathematics Day. It was introduced in 2012 by the Prime Minister of Dr. Manmohan Singh. So this Srinivasa Ramanujan, born on 22nd December 1887 in Madras and in British India, and unfortunately he died at very early age, at the age of 32 on 26th April 1920, and he was awardee of Fellowship of Royal Society, Mathematical Society. So basically, in very less time of his span of his life, he has done really wonder in the field of mathematics. So let's see. So basically, we call him the god of numbers. So an equation means nothing to me unless it expresses a thought of God. That's what S. Ramanujan said. So basically, he connected the numbers with the spiritual things. Like he used to see the God, like he suppose he instantly found some result, whatever there are so many results which was really not like unsolved. There are so many results which were unsolved, but Ramanujan was the one who instantly solved those results without giving any proof. So he used to find out the result and very big number, and he used to play with the numbers, just like just that's why we say that the man who knew infinity. And so he went to like Ramanujan was very in India. No one was able to recognize his talent and work. Then he used to tried to meet these two mathematicians, G.H. Hardy and J. Littlewood. These two mathematicians were supervisor of him, and then G.H. Hardy told that I had never seen anything in the least like them before. A single look at them is enough to show that they could be only written by a mathematician of the highest class. They must be true, because if they were not true, no one would have the imagination to invent them. He also said that like other great men, he invented himself. So it is all about the spirituality and relation between mathematics and God. So now his academic supervisor said that every positive integer is one of the Ramanujan personal friend. So he used to play with the number like that. So just like once upon a time when Hardy came to see Ramanujan in the Tamil Nadu Kumkodam, his taxi number was like 1729. And this number got famous with the name of Hardy Ramanujan number. And this was the number that was played by Ramanujan in a various way. So this 1729 was the taxi number, and he used to write this number as a sum of cube of two numbers. So now you can see in the very top, 1729 has been written like 1 cube plus 12 cube. It can also be written as 9 cube plus 10 cube and so on. So these are the references and so on. So I have not written in very detail, but you see that the same number, again, he was playing with the same number in a very different way. So there is another thing that is called magic square with 1729. So he made some square, magic square. So what is this magic square? Let's see. So there will be a square. These are the very, very basic things I'm discussing with you. So Ramanujan did this magic square with his date of birth. So 22nd December 1887 was his date of birth. And now you can see the first magic square. So first of all, this is called the magic square of order 4. So if we add the number row wise or column wise, we will get the same number. So now you can see in the first magic square, 22, 12, and then 18 and 87. If we add these numbers, it will be equal to 139. So he found various numbers which can be written as 4 cross 4 matrix, and then sum will be whether you will sum, we will take the sum from the row wise or you will take the sum from the column wise. Each column and each row will have the same sum. It will be 139. So he did not stop. He also made another magic square and so on. And now one can observe that 139 is a prime number, and sum of all these date of birth is 139. So give any number, Ramanujan will do something with that number. So he will make something different, and something he will play something differently with that number. So now you can see again here 1729, the same number. He is writing this number as a single digit representation. Again in the fourth, he is writing the same number in this way. Now you can see that. Again, the same number, he is playing the same number with different way. So he has written this 1729 in increasing and decreasing thing. Like you see that this number, the representation is written like that. Now ending in 0, like this 1729 can be written as with ending factorial 0. You can see that. Now number from 1 to 10 and reverse. So he is again writing the same number in the another way. And then you can see there are so many other representation of the same number 1729. So that's how we can see that you give any number in the world, whether it is big, whether it is small, Ramanujan could play with that number in a very, very various ways. So now you can see again 1729. So this is one of the example how he could play with a single number in a many different way. So now you can see that 1729 can be written as a same pattern like that in 7.3 addition. So how can it be written like that? Addition of the similar pattern of the numbers, like 1729 is equal to 35 plus 35 plus 36 plus 40 plus 83 and plus 1500. Then you can see below number as 1500, 1501, 1501 and so on. Now you can see that last digit, this is the representation of again that same number 1729, and you can see that the last number is again 1500 on one only in every representation. So this is the pattern of representing the same number. So now again this is another representation that is called narcissistic type, flexible power with division. So now you can see that this number can also be represented like that. And then in the power of 2, how can we write this 1729 in the power of 2? So 1729 can be written as 6 square, 18 square, 37 square and so on, and various squares, sum of various square you can write. In the power of 3 you can also write 1729 1 cube plus 12 cube, 9 cube plus 10 cube and so on. And power 3 multiplication, you can see that. So now for this basic work of Ramanujan, I have given two references. You can check it out. The one is Inderjit Taneja Research Report Collection. You can see all the basic work of Ramanujan in this paper. And the second paper, you can see how can you can write any number as a sum of two cubes. It has very, very interesting proof. So these are the basic works. And also there are various higher research, so that I'm not going to discuss. So I think if you see all these things, you will really wondering the work about the Ramanujan. So now the next thing is mathematics omnipresent? So I feel it is. Yes, it is. As you can see that mathematics has also been used in machine learning also. So yes, mathematics is omnipresent. So this is my personal opinion. If you mathematics is not a subject, basically it is a feeling, and once you understand mathematics, it never leaves you alone. So now this is my personal philosophy about the life and mathematics. So everyone knows what is the Cartesian plane. So one must wonder, the positive x-axis goes in the forward direction and positive y-axis goes in the upward direction, and that is the first quadrant. So if you have positive thinking in your life, if you do any work with positive attitude in your life, means in the x-axis direction there is a positive, right? In y-axis direction there is a positive thing. So if you stay in the first quadrant, then your life will be positive and happy. You will always go forward and you will always raise yourself upward. Even if you see that if you come in the second quadrant will take you backward on the left hand side. So this is a negative x-axis. So once anything you will take negative, it will drag you in the negative direction. It means in the backward direction. You will not able to go forward. So always stay in the first quadrant. Make your life happy and positive. So I wish you all very great, happy and successful life ahead on this great occasion of birth anniversary of Srinivasa Ramanujan. Thank you. So I had not very much, it was very less time, so I'm sorry. I did it very sorry.
I was not audible. Thank you so much.
Yes.
Who you your time and experience you have shared with us today. We are very much thankful to you, and we are very much obliged that you came in. Thank you so very much that you told us about man who knew infinity. Thank you so very much. I now can see that there are many questions have been answered by Mr. Sujit. Thank you, sir. But there are many students who want to ask questions from you directly. So first we have Mr. Amrit. Abhinav, I request you to please unmute.
It is requested to open for
I'm sorry, I'm not able to hear. Is there a question for me?
Yes, sir. There's one student who want to ask question. Mr. Abhinav, I request you to unmute.
it is requested to give them the permission.
Yes, sir, I am giving permission. Abhinav Tomar, please accept my request.
Abhinav, accept the permission and ask your question.
Nidhi Mittal, if you are there, you can also unmute if you are listening to me. Nidhi Mittal. Yes, Nidhi, you can now start asking your question.
Nidhi, be on camera.
Nidhi ma'am, you can unmute yourself.
Am I audible?
Yeah, please.
So I have a question. Why Python is better than C++ and Java?
Okay, it's not necessarily that Python is better than C++ and Java, but for the area of machine learning, it is the most often used language. And as a learner, you will find a tremendous amount of help available if you learn Python and implement machine learning through Python. about it is definitely the most dominant language in the area of machine learning. So firstly, it's very easy to learn, and then also the machine learning libraries are very well developed, and you can do really awesome things with it.
Okay, thank you so much.
Okay, Abhinav, if you are there, you can now unmute and ask question. I think he is not able to mute. So we will now proceed further. And I thank you, sir, for coming here and sharing your words with us. And on behalf of Amrit University, Great Noida, I convey my hearty gratitude to all the speakers for sharing their graceful word with us today in this webinar on Amrit Mahotsav. And I'm thankful to all the faculty members, staff, and students for attending this session. We have been fortunate to have the renowned identity, and I'm sure that our college will continue to get significant innovation from the diverse group. Thank you so very much for being here. Thank you.
May I request to you all be on the camera, please, for a while? Well, thank you, everyone. Thank you, Mr. Sujit Bhattacharya ji, Dr. Priyambada ji. Surely, whenever the situation will be normal, you're most welcome physically in the campus.
Sure. Thank you so much.
Thank you so much.
Thank you.